All right, so for today, we're going to be talking about triangles, a lot of triangles. We're going to talk about congruence, we're going to be talking about similarity, we're going to be talking about from previous units, the side angle side. All those wonderful things are going to kind of come back in this little section of notes. So, our essential question is the same as yesterday, right? We're going to select, apply, and adapt a variety of mathematical strategies related to similarity. Again, we're going to focus on triangles for the most part today and the side angle, side, all that stuff we learned. I believe it was 2 topics ago in first semester. So, number one, it says, can you use a sequence of transformations to determine if triangle ABC is similar to DEF? So, can we get it to this triangle? Can we do some stuff to it to make it turn into this triangle? Well, the online version actually does a good job of this. So I'm going to flip over to it, right? And then it says, how is a congruence a special case of similarity? So this is the online version, right? We have reflection tools, we have rotation tools, we have translation tools, and dilations. If we took the reflection tool and we reflected it about the line, okay, we can now move this to the other side. Okay? Then after we rotate it, then we can dilate it. Whoa. And we can move our dilation, and you can see how big and small it gets. And we can try to get the same size. If you would like, if you guys can log online, and you guys can mess around with this if you guys like. In there, let me see if I can get this close. There's the reflection. Let's see if we can do the dilation. We're going to try and dilate it a little bit smaller. Let's say there. And then we can move it. And you guys see how it's almost exactly the same? Look at that. So what are the 3 things that I did? I reflected it, I dilated it, and I translated it. So in our notes here, is it possible to take this image and turn into this image, or this image and turn into this image? Yes, you can. What are the 3 things you need to do? Number 1, we need to do a reflection. Number 2, we need to do a dilation. And then number 3, we need to move it on top of the other one, so we did a translation. So is it possible to show these 2 triangles are similar? Yes, it is. All you have to do is follow those 3 steps. Okay, so number 2. How is congruence a special case of similarity? Well, congruence is a similarity, but it is special in the fact it's when the scale factor is 1. Okay? That means that the pre-image and the image are under the same exact dilation. So congruence is a special case of similarity when the scale factor is 1. So all we're going to do is focus on when the scale factor is 1 for when we have congruence. Number 3, can you construct 2 triangles in which the 3 angles of one triangle are congruent to the 3 angles of the second triangle, but the triangles are not similar? Okay, so again, the online version actually does a really good job of this. So in the online version, let me show it to you guys. It is right here. So if you guys remember, we are talking about angle. In our previous topics, we talked about side, which is if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. We talked about side, which was the side and the angle that is included between the 2. We talked about angle, which was 2 angles in the included side. And we talked about side, angle, which was the non-included side between 2 angles. And these pictures, if I'm going to zoom out here, might actually help you guys out a little bit more, right, if you guys look at these pictures. So that's the online version. So what we're going to talk about is angle first. So it says, if I had a triangle, right, is it possible to create another triangle that is similar if all the angles are congruent? So I can do any of these triangles. So 1, 2, 3, or 4. Any of these triangles. It doesn't matter. And what the online version does is it takes a triangle, so there's this triangle, and it creates my angles. So is it any way that I can move or rotate these things around to make a triangle that is not congruent to my original triangle on the bottom? And as I move this around, you guys will see it's impossible to make a triangle that way. I can't make a triangle this way. And you guys can screw on with this. I can move these around. I can move this around, right? There's a whole bunch of different ways. What it's trying to show you is that it is impossible to do what number 3 is saying. It's impossible to do this. It is impossible to construct two triangles in which 3 angles of one triangle are congruent to 3 angles of the second one, but the triangles are not similar. They are always similar. So based on our conclusion here, what can we say? We can say this. We're going to have a little bit of writing to do. We can say, no, it's impossible, right? If 3 angles of a triangle are congruent to the 3 angles of another triangle. So I'm just restating our statement, right? Then the triangles must be similar. It's impossible not to be. They must be similar. Okay? So what does this all mean? This means that if I have 3 angles of one triangle congruent to 3 angles of another triangle, they must be similar. So therefore, we can say that A postulate for triangle similarity. So when we're talking about similar triangles, we can use AAA to prove that the 2 triangles are similar. Okay? So we're going to practice this stuff in a couple problems. We're going to go through some other ones. And we're going to show AAA. We're going to show AA. I believe we're going to talk about side, side, side. We're going to talk about side, angle, side. So this next one on the next page. So suppose 2 angles of one triangle are congruent to 2 angles of another triangle. Using the triangle sum theory or theorem, what could you conclude about the third angles in each triangle? Justify your answer. So for this one, I think it's easiest to draw a picture. So let's draw a picture. So I'm going to draw a triangle. There's the first one, right? Let's label this. Let's label it as A, B, C. Then if I drew a bigger triangle, so there's my bigger one. Let's call it D, E, F. Those almost look identical, right? If, this is saying, suppose 2 angles of one triangle are congruent to 2 angles of another. So if I said, right, this angle is congruent to this angle, if I said the top angle is congruent to the top angle, then what can we conclude about our third angle? Okay, do you guys remember what the triangle sum theorem is? Hopefully you do. Triangles, right? 3 sides or 3 angles. Sum means we're adding everything together. So if I add the angles of a triangle together, what number should I get? Well, that is 180 degrees. So if I took angle A and I added on angle B and I added on angle C, I should get 180 degrees, right? This one, if I took angle D and I added on angle E and I added on angle F, I should get 180 degrees. Now, both of these things equal 180 degrees. So what can I do? I can set these things equal to each other. So I can say A plus B plus C is equal to D plus E plus F. So all I do is take my two equations and put them equal to each other. So now from here, we know, I'm going to highlight as I go, we know that A and D are the same. So what can we say about A and D? They're the same thing. We can also talk about B and E. B and E are the same thing. So what I can do is I can do some substitution, right? I can still do A plus B plus C, but instead of D, E, and F, instead of the D is the same as the A. I'm going to put it as an A plus, instead of an E, I'm going to put it as a B plus F. And now from here, I can just solve this thing. If I subtracted A from this side, I'd subtract A from that side. My A's would cancel out, leaving me with B plus C is equal to B plus F. Now from here, I could subtract B, I could subtract B, and my B's would cancel out. So now I'm left with C is equal to F. Oh my gosh, C and F. So I'm going to highlight in blue. Angle C, which is my third angle, is the same as angle F, which is my third angle. So therefore, what can we conclude? If you have two angles of one triangle congruent to two angles of another triangle, we can conclude that the third angle is also congruent. So what does this all mean? What this means is, instead of simplifying or using AAA, we can simplify it to just AA similarity. So let's write down the actual definition of AA similarity so that way you guys can use it on your tests, on your proofs, and all that stuff. So AA similarity is if two angles of one triangle are congruent to two angles of another triangle then the two triangles are similar. Whew, there it is. So we went through all of that just to show that if you have two angles that are congruent in one triangle and another triangle, then both of those triangles have to be similar. All right, number 6. Number 6, it asks us to use a compass and a straight edge to construct a triangle with side lengths 2, 4, 5, and other triangle side lengths 4, 8, and 10. Then measure the angles in the two triangles. Are they the same? What does this tell you about triangles? Now, granted, I'm not in class. We probably do this in class with compasses and protractors and all that stuff, but since I'm not there, I'm not going to have you guys go in a closet and find them. So we're just going to use the online version. So in the online version, it'll pop up here in a second. We did that, we did that, we did that, we did that, we did that. Come on, where'd it go? I don't think it has it in here. I swear to God, I had it. I'm not going to spend all time looking for it. Okay. So, for this problem, we're just going to draw these, and I'll just talk to you guys through it. I thought it was in here. That was the AAA we just did. There it is. So, on your paper, right, with the straight edge, construct two triangles whose sides are proportional. For example, construct a triangle with a 2, 4, 5 and another with a 4, 8, 10. Then the measure of the angles in the two triangles are the same. What does this tell you about the triangles? So what we're going to do is we're going to draw two triangles, just like this. A 2, 4, 5 and a 4, 8, 10. So in your guys' notes, just draw two triangles where it looks like one side, right, is a 2, this side is a 4, and this side is a 5. Then draw another one where it's a little bit longer and a little bit bigger, where this one is a 4, this one is an 8, and this one is a 10. So there's my two triangles. So it's asking us, right, are they the same? What does this tell you about the two triangles? So from looking at this side matches with this side. So the 2 and the 4 match up. The 4 and the 8 match up. And then I don't know what color I should use. Let's use yellow. The 5 and the 10 match up. And if you notice, 2 to 4 is multiplying by 2. 5 to 10 is multiplying by 2. 4 to 8 is multiplying by 2. All of these have the same scale factor, which is times 2. So are they the same? No, because they're not congruent, but they are similar. So what can we say about this? We can say the corresponding angles are congruent, so the triangles are proportional. Now, if we had a compass or a protractor and compass, we can measure all these angles, and we would find that all of these angles are also congruent. 1, 2, 3. 1, 2, 3. So this is just practice using it. It's supposed to be a little activity and have a little bit of fun. But again, I'm not going to have you guys pull out all that stuff. So as long as you guys are understanding the similarities, the sides are proportional, and all the angles or corresponding angles are congruent. All right, number 7. Number 7, we're going to go a little bit deeper. We're going to talk about SSS, aka side, side, side. So how would you state the side, side, side similarity postulate? So what we would say is if 3 sides of one triangle are proportional to 3 sides of another triangle, then the 2 triangles are similar. And we kind of just went through this, right? I just showed that same exact thing to you on the triangles above, the 2, 4, 5 and the 4, 8, 10, right? I showed that all the sides are proportional with the scale factor of 2. So therefore, the left triangle and the right triangle are similar or proportional. So for number 8, it's going to ask us to kind of use this stuff. So it says, can you construct 2 different triangles that are not similar, but have 2 pairs of sides proportional and a pair of included angles equal in measure? Try to do this below. Based on your response, what can you conclude? So what it is saying is if I draw an angle. Whoops. Shoop. Come on, draw an angle. There's one. There's two. So if I have one angle here, and I'm going to draw a smaller one, I'm going to try and make it the same. So there it is. So if I have one angle congruent to another angle, right? And I have my sides proportional. So this top side here is proportional to this side, and this side is proportional to this side. Is it possible to add a third side that would make this triangle not similar to this one? So what it means is, can I change this triangle? So using an iPad, can I make it bigger, turn it, make it smaller? Can I do anything to this to make it where it won't match this left triangle? If you guys would like to try and screw around with it and can, I'm going to tell you right now, it is impossible to do, because the only thing that you can do is you can only connect this side and this side. The only thing you can do on our small triangle is connect the side and the side. And I can show you a million different ways, whether it's big, small, whatever. I can always make it match up to our sides when everything is perfect, okay? Everything needs to be proportional. Everything will work out. So by this, I'm going to label it. I'm going to show you guys exactly what I mean. Whoa, what did I just do? I don't know what I just did. Something just got screwed up. Edit, undo. There it is. Okay. If I have this triangle A, B, and C, and I have triangle D, E, and F. Okay. If I'm able to show you that the distance from AB is proportional to the distance of DE, and I'm able to show you the distance from AC is proportional to distance to DF, right? And I'm able to show you the last one, which would be BC is congruent to EF. If all of these are the same, then our triangles are similar, okay? So in our problem, I don't know, if I gave you guys an example, if I said this is a length of 8 and this was a length of 4, and if I told you this was a length of 4 and this was a length of 2, right? I could then say that this thing is 8 divided by 4, which is 2. I could then say 4 divided by 2 is equal to 2. And my last side here, there is no way to create this last side where this number is not the number 2. Okay? So that's what it's talking about. If you like to screw around with it, mess around with it, you guys can. Moral of this story is trying to say, based what can you conclude? We can conclude that triangle ABC is similar to triangle DEF. Remember, this is a symbol for similar, okay? We've talked about the symbol for congruent before, which is this symbol, right? So the symbol for similar, we now get rid of the equal sign, and it's just this little squiggly line. That is the symbol for similar. Again, I'm hoping this makes sense to you guys. It's actually kind of really hard to do a video and explain this stuff with you guys without seeing your facial expressions and seeing how confused I'm making you guys. Hopefully this is making sense. If not, hopefully, I mean, there's 3 teachers in the room. Hopefully one of them can help you guys out until I get back. Okay? If you are really stuck and confused, just let one of the teachers know. And next week when I am back, I can request you guys for JIT time. I can help you guys out during JIT before the test comes. Number 9, numero 9. How could you modify the SAS postulate to show similarity instead of congruence? So if we wanted congruence, we would have to show that the 2 triangles are congruent by showing the sides are the same and the angle is the same. But we're going to talk about similar this time. So instead of having two sides congruent, we need two sides that are proportional. So it's almost the same exact thing, side angle side congruence, but instead of showing congruence, we're going to show that the two sides are proportional, which is basically what we just did above. So how would I actually write this out in terms of the rule that you guys can use? So for number 10, how would you state side angle side similarity postulate? We would state it like this. If two sides of one triangle are proportional, to two sides of another triangle, right? So now we have the sides are all proportional. And the included angles are congruent then the two triangles are proportional. I know, a lot of writing. Guarantee you, I can envision the people in the class right now who would be complaining about how much writing there is. Yes, abbreviate if you need to. That is okay. So we talked about side, side, side. We talked about side, angle, side. And we talked about angle, angle, angle similarities today. So our last little steps are we're going to do a proof. And we're going to talk about that proof and we're done. So we've talked about proofs before, everyone's favorite, right? You guys actually do a really good job with proofs. So it says, fill in the blanks to complete the proof. So if we are given AB is parallel to DE, so I'm going to mark that on here. AB is parallel to DE, right? We use the little caret, the little arrow symbols, however you like to think about it, to show that is parallel. And if you guys remember anything about parallel, you guys should start to think about the corresponding angles, the alternate interior angles, right? The vertical angles, the same side interior, like all those things from, I think it was like what, topic 2 when we did it all the way back when in first semester. So we want to prove that ABC, so ABC, which is this, ABC is congruent to triangle DEC. So those are my two. Prove that those are all congruent. So I want you guys to actually go through, try and fill in this proof on your own first, then come back and see what I come up with, right? Just like how I usually do when I'm in class with proofs. Try it on your own first, see if you can fill in the blanks, and then come back. All right, hopefully you're back. So in our beginning, we have our statement and we're given, right? That's always how we start out every single proof. Next, we can say that ABC is congruent to CED. So I'm going to mark it up here. ABC is congruent to CED. And how do we know that? We know that by alternate interior angle theorem. Right? Remember us abbreviating it to AIA instead of writing it all out? Then the next step, we can say BCA is congruent to CDE, right? By vertical angle. So we can say that this part in the inside is congruent to that one. So I'm going to put it in here. Angle BCA is congruent to angle DCE. How do I know that? Vertical angles. And then our last part, I have everything I need. I have two angles that are congruent, so I can show that these two things, or these two triangles, are similar by AA similarity. If you like to use the word postulate at the end. So AA similarity postulate. So now we go to number 12. Are the two triangles in the diagram similar? How do you know? So, in this, we know they're similar by SAS. And this is actually this picture. So let me pull it up for you guys. Boom, boom, boom. Yep, we did that. We did that. There it is. So in this picture, do we know that if I was giving you this picture, do we know that the small triangle is similar to the big triangle? And if you notice, this picture looks like the proof that we just did above, right? We have vertical angles, we have lines that are parallel. So we can say that those two triangles in the diagram are similar. How do we know they're similar? We know they're similar by side, angle, side, similarity. Well, what do you mean by that? Well, we know, right, that 3/4 is proportional to 30/40. And by that, I mean, right, you can see 3/30, 4/40, right? We're just multiplying by 10, right? Or if you're going from the big one to the small one, we're dividing by 10, whichever way you like thinking about it. So we have, how should I write this? So SAS similarity, 3/4 equals 30/40. So the two sides are proportional, right? We have the two sides are proportional, and the included angle is congruent. If you guys want to see like the small picture, right? This is what we're talking about. I'm just making it a little bit bigger so that way you guys can see it, right? We had 3, 30, 4, 40. We know that this side is proportional to this side. We know that this side is proportional to this side. And we can also say through vertical angles that this angle is congruent to that angle. So there's a small little picture showing side, angle, side. Last one, 13. How can you use the diagram above to find the distance across the pond? Well, we know that has a scale factor of 10, right? So we can find the unknown side. Whoops. By using the scale factor of 10. So all we have to do is find out. I'm gonna copy my picture here. Copy, I'm just gonna make it a little bit bigger. So if this is my triangle, right? If I know that this is 3.4, the distance from here to here, all I have to do is multiply by 10 and I can find out that is 34. If I found out that this side was a length of 5, all I have to do is multiply by 10 and that side is 50. So all I have to do is use my scale factor of 10. That's it. Again, if you're lost or confused, let me know. When I come back on Monday, we'll get you guys signed up for JIT.